Obtain the transfer function C of S upon R of S. Obtain the transfer function C of S upon R of S using block diagram reduction technique. In this case, we have to see the innermost part. Innermost part is this G1 and G2. But one takeoff point is there. That's why we cannot multiply these two. Either we have to move this to this side or this side. Suppose if you want to move to the left side, what will happen? The signal is the signal going to this G4 already multiplied by the gain G1, transfer function G1. If you shift that, it will not be multiplied by G1. Therefore, we have to multiply by G1. So what we can do is G1, G2, G3, here G1, G4. Now, this can be separated into two summing junction and these two can be multiplied together. This can be multiplied together. If you multiply these two together, what you will get? G1, G4. If you multiply these two together, you will get G1, G2. These two are in parallel. And you can separate this like this. In this diagram itself, we could have done like that. This is G1, G4. Here, G1, G2. These two are coming from R of S. Again, another summing block, G3, H1, C of S. This is minus sign. This is also minus sign. This is plus. This is plus. This is plus. So this, by using seventh rule, we can simplify this. So this is equal to what? G3 upon, because negative feedback, that's why 1 plus G3 H1. These two are parallel, that's why we can write G1 G4 plus G1 G2 for this. Then one more feedback, that's all. So we can simplify the given block diagram as in this G1 G4 plus G1 G2. And it is given to G3 upon 1 plus G3 H1. So now these two are cascaded blocks. Now these two can be multiplied together. What we will get is G1 G4 plus G1 G2 multiplied by G3 upon 1 plus G3 H1. This is in the numerator. Forward path. R of S, and this is C of S. Now we have to apply the seventh rule and simplify this. Here feedback is 1. No block is there, we have to take it as 1. So what we get is 7. If we apply 7th rule, forward path transfer function G1 G4 plus G2 G1 G4 G1 G2 G1 G2 multiplied by G3 upon 1 plus G3 H1. That's what we got. G3 H1 whole divided by, because of this feedback path, 1 plus the entire thing we have to write. G1 G4 plus G1 G2 multiplied by G3 upon 1 plus G3 H1. If you take LCM, these two get cancelled. So this is equal to G1 G4 plus G1 G2 multiplied by G3 upon 1 plus G3 H1 upon, if you take LCM, what you will get? 1 plus G3 H1 plus G1 G4 plus G1 G2 multiplied by G3 upon 1 plus G3 H1. This and this getting cancelled. Therefore, G1 G4 G3 plus G1 G2 G3 upon 1 plus G3 H1 plus G1 G4 G3 plus G1 G2 G3. So this is the final transfer function. So we simplified. So this system is represented by 1, 2, 3, 4, 5 differential equations. If we know the transfer function, we can substitute here and we can find a single transfer function. So that is possible by using block diagram reduction technique. This technique is called block diagram reduction technique. Another method is signal flow graph method. We can represent this block diagram in terms of signal flow graph. So the same block diagram can be represented in signal flow graph. For that, R and C are called node, you know. Already studied node in circuit, electric circuit analysis. Node means junction, but misnamed. Even two elements are meeting, we are calling it as node. So like that here, R is one node and C also another node. This is called source node. And this C is called sink node. Starting node is called source node. End node is called sink node. All other takeoff point as well as summing points will be marked as node. First node, this is second node, this is third node, fourth node, fifth node, sixth node, seventh node. Therefore, C is seventh node, R is first node. Now we can draw all other nodes. Second node, third node, fourth node, fifth node, Sixth node. That's all. We have to mark the directions. Direction is from 1 to 2. From 2 to 3. 3 to 4. 4 to 5. 4 to 5. 5 to 7. 5 to 6 also in the same direction. That's why 5 to 6. Then 6 to 4. 6 to 4 this direction. 6 to 2 also the same direction. Feedback direction. And 3 to 4 one direction. 3 to 4. That's all. We have marked the direction only. Now we have to mark the gain. This type of representation is called signal flow graph representation. Signal flow graph representation. SF representation. Signal flow graph representation. In the signal flow graph representation, each link will have a gain. For example, this may be G1 between node 2 and 3. If no transfer function is there, for example, between 5 and 6. 5 and 6, if you see, no transfer function, gain is unity. That's all. So these and all we have to mark. That's all. 1 to 2, no gain, no transfer function, 1. 2 to 3, G1 is there. 3 to 4, G2 is there. 3 to 4, another one is there. That is also G4. That is G4. 4 to 5, G3. 6 to 4, H1. But here negative feedback. That's why minus H1. Negative feedback. That's why minus. Here, no transfer function is there, but minus. Therefore, minus 1. 5 to 7, no transfer function, therefore 1. All marked G1, G2, G3, H1 and G4. Everything is marked minus 1 for 6 to 2. This representation is called signal flow graph representation. Each link has a gain. Each link has a gain. Each link has a gain. That's all. To find the transfer function, one formula is there that is called Mason's gain formula. Mason's gain formula. The transfer function T of S equal to 1 upon delta sigma Pk delta K. Pk delta, that is the formula. Sum of Pk delta K. 1 upon delta sigma Pk delta K. Where Pk is kth forward path. Forward path gain product of kth forward path, that is Pk. Gain product of kth forward path, Pk. Here, how many forward paths are there? The source is R, destination is C. To reach the destination, there are 2 forward paths. One is 1, 2, 3, 4, 5, 6, 7. Another forward path is 1, 2, 3, Through this, we have to reach 4. Through the circular path 4, then 5, 7. There are 2 forward paths. So there are 2 forward paths, P1 and P2. The gain products of P1 is G1, G2, G3. The gain product of first forward path P1 equal to G1, G2, G3. Whatever the weight there, we have to multiply. That's all. Gain product for the second forward path P2 equal to G1, G4, G3. That is PK. We got PK. How many Ks are there? 2. Only 2 forward paths are there. Only 2 forward paths. One is G1, G2, G3. Another forward path is G1, G4, G3. That's all. To reach 1 to 7. No other forward path. This is one-way traffic. You cannot travel through this because direction is important. You cannot travel this path. 4, 6, 5, 7, you cannot travel because direction is against. Similarly, you cannot travel 2, 6, 5, 7, but you can travel 1, 2, 3, G2, 4, 5, 7, you can travel. 1, 2, 3, G4, 4, 5, 7, you can travel. These only 2 forward paths are there, whose gains are G1, G2, G3. Another gain is G1, G4, G3. That's all. What is delta? Delta is 1 minus. Delta is the name of delta is determinant of the graph. That is delta. But definition only if you know, that is sufficient. Determinant of the graph delta equal to 1 minus sum of gain products of individual loops. Loop means suppose you are starting at 2 means I am traveling like this. 2, 3, 4, 5, 6, again 2. That is one loop. Another loop I am telling. 2, 3, G4, 4, 5, 6, 2. Another closed loop. Another loop. One more loop I am telling. 4, 5, 6, 4. These are all loops. These are all loops. The gain product of loops means whatever gain you mentioned, you multiply all those things. Gain product, what is it? First loop, L1. L1 equal to what? G1, G2, G3 minus 1. Therefore, minus. This is equal to minus G1, G2, G3. L2, second loop, sum of gain products of individual loops. Single loops, individual loops or single loops. Sum of gain products of another loop is what? G1, G4, G3 and minus 1. How I am traveling? G1, now I am traveling G1, G4, G3, then I am coming here. This is second loop. This is L2. First loop is how? First loop is this way. First loop is this way. Third loop is what? Third loop is 4, 5, 6. 4, 5, 6. L3 is L3 equal to 4, 5, 6. G3 minus H1. Because H1 is in minus. Gain of 5 to 6 is 1. Gain of 5 to 6 is 1. L1, L2, L3 were. Delta equal to what? 1 minus sum of gain products of individual loops. That is nothing but L1 plus L2 plus L3. L1 is what? Gain products of individual loops. Gain products of individual loops. L2 is gain products of another individual loop. L3 is gain product of another individual loop. This is not loop. I am traveling this way. 3, 4, 3, G4, 4, G2, 3 is not loop. Why? Why it is not loop? Direction is not in favor of traveling. If you travel 3 to 4 through G4, you are traveling as per direction. If you travel from 4 to 3, it is against direction. So you cannot travel. I understand that. Only 3 loops are there, not 4 loops. This is not loop. This is not loop. This is not loop. This is not loop. Not loop. Why? Because 3 to 4 you can travel through G4, no problem. But you cannot travel 4 to 3. Again, you cannot reach the same point. There is no path. Because the direction is not in favor. Direction is not in favor. That's why it is not loop. Loop means the direction also must cooperate. Then only you can reach the same point, means it is a loop. But if it is different path, means different loops. There are only 3 loops are there. In the diagram, only 3 loops are there. What is delta? Delta is 1 minus sum of gain products of individual loops plus, I am putting minus here, now plus sum of gain products of two non-touching loops. Non-touching loops. Sum of gain products of 2 non-touching loops. Is there any non-touching loop? You see that L1 and L2 are touching each other. L1 and L2 are touching each other. L2 and L3 are touching each other. L1 and L3 are touching each other. Therefore, there is no 2 non-touching loops. How we can group this? 2, 2, 2. If you group this as 2, 2 loops, L1, L2, L2, L3, and L1, L3. Only 3 possibilities of combinations. 2 non-touching loops. If you check L1 and L2, they are touching each other. That's why they are not touching. They are touching loops, not non-touching loops. What is the formula? Sum of gain products of 2 non-touching loops. But they are touching. That's why you cannot take. Have you understand this point? L1 and L2 are touching each other. Therefore, they are not touching loops. They are not non-touching loops. They are not non-touching loops. L2, L3, if you take, they are also touching. Therefore, they are not non-touching loops. If you take L1 and L3, they are touching each other. Therefore, you cannot take. Therefore, second term, you won't get. The green term, you won't get. Now, if you take one more term, if you write the third term, sum of gain products of 3 non-touching loops. 3 non-touching loops. There is no 2 non-touching loops. Then how 3 non-touching loop will be there? Definitely it won't be there. Etc. Here minus sign. Here minus sign. Plus sum of gain products of 4 non-touching loops. Infinity, up to infinity. There is no 2 non-touching loops. How there will be 3 non-touching loops? No, 4 won't be there. That's all. Therefore, this term is not there. This is also not there. The formula delta equal to 1 minus sum of gain products of individual loops. Now I think you got the meaning of individual loops. All loops must be taken first time. Second time, if they are not touching 2 loops, a group of 2 loops not touching each other means Then you can consider. For example, I am having a loop like this. Non-touching loop, I will give you example. One forward path. One loop is here. Another loop is here. Another loop is here. This is L1. Loop 1, loop 2, loop 3. L1, L2, if you consider non-touching. L1, L2 are non-touching loops. L2, L3, non-touching loops. L1, L3 also non-touching. L2, L3 also non-touching. Therefore, three components you will get. Suppose the gain of this L1 is G1, H1, G2, H2, minus H2, minus H2. G3, H3. For example, the second term you will get L1, L2 equal to G1, H1 minus L2, L3 equal to, G1, H1, G2, H2 plus, because both minus, that's why it becomes plus. If you consider L2 and L3, you will get G2, G3, H2, H3. Positive. Why? Both are negative. Then what you will get? L1, L3. They are also not touching. Therefore, G1, G3, H1, H3. Sum of these components has to be substituted in the place of green term. In this case, no two non-touching loops. If it is there, we have to consider. If it is there, we have to consider. In this case, is there any three non-touching loops? Yes, it is there. L1, L2, L3 are not touching each other. Therefore, you will get one term L1, L2, L3 equal to G1, G2, G3, H1, H2, H3 minus, because three negative terms, therefore minus. Have you understand this? So like that you will get, but here no two non-touching loops, no three non-touching loops. Therefore, no three non-touching loops. There is no two non-touching loop means how there will be a three non-touching loops. Definitely won't be there. Only three loops are there, four non-touching loops, how it will be there? That's why you need not bother. So it's we should be careful about number of loops. If you lose some loops, some will be wrong. That is the drawback with this sum. Okay, now we got L1, L2, L3, only individual loops, no non-touching loops. We can write the formula. Delta means what? 1 minus sum of gain products of individual loops. All of the terms are not there. There is no two non-touching loops. There is no three non-touching loops. That's all. So delta is we got. Delta we got. Now we do not know what is the meaning of delta K. That we have to find. In that formula, P1, P2 we got two forward paths are there. Forward path gains are G1, G2, G3, G1, G4, G3. That we got. But what is delta K? Delta K is delta 1. How many Ks are there? Only two Ks are there. Delta 1, delta 2. Because P1, P2 is there. Two forward paths are there means delta also only 2. Delta 1, delta 2. Delta 1 means delta is delta of part of graph which is not touching the forward path 1. Which is not touching the forward path 1. What is the forward path here? This is the, I will draw in the block diagram because here you cannot understand. That's why this is the forward path 1. Is there any loop which is not touching the forward path? No loop. Therefore, delta 1, delta of delta forward path P1 equal to 1. That's all. Because formula starts with 1 minus. Starts with 1 minus, only 1. Because no loops are not touching the forward path. Second forward path, which is second forward path. This is the second forward path. This is the second forward path. This is the second forward path. In the second forward path, any loop which is not touching the second forward path, no. Therefore, delta 2 also equal to 1. delta 2 also equal to 1. If you combine all these things, you will get the transfer function. If you combine all these things, you will get the transfer function. Let us combine. What is the formula? Mason's gain formula. T of S, that is C of S upon R of S, that is the transfer function, equal to 1 by delta sum of P1 delta 1 plus P2 delta 2. Sum of means what? P1 delta 1 plus P2 delta 2. What is P1? P1 is G1, G2, G3. What is P2? G1, G4, G3. What is delta 1? 1. What is delta 2? 1. Therefore, what is delta? Delta equal to L1 plus L2 plus L3. So we can substitute here and you will get the transfer function. What is that? We will write here so that we can compare. C of S upon R of S equal to, what is P1 delta 1? What is P1? P1 equal to G1, G2, G3. P1 equal to, formula is what? P1 delta 1 plus P2 delta 2 upon delta. That is equal to P1 equal to G1, G2, G3 plus, what is P2 multiplied by delta 1, that is 1. What is P2? G1, G4, G3 upon delta 1 minus delta L1 plus L2 plus L3, that is equal to G1, G2, G3 plus G1, G4, G3 upon 1 minus, what is L1? What is L1? Minus G1, G2, G3 minus G1, G2, G3 minus L2 is G1, G4, G3. G1, G4, G3. What is L3? Minus G3H1. Minus G3H1. Minus G3H1. Therefore, the given transfer function is G1, G2, G3 plus G1, G4, G3 upon, because all terms are with negative, that's why 1 plus G1, G2, G3 plus G1, G4, G3 plus G3H1. What we got? G3H1 in the 1 plus is there. Here also 1 plus. G3H1, yes, it is there. G1, G4, G3, that is also there. G1, G2, G3, that is also there. The numerator G1, G4, G3 is there. G1, G2, G3, that is also there. In both methods, we got the same result. The first method is called block diagram reduction. The second one is called signal flow graph. You have to convert the given block diagram into signal flow graph, and then you have to obtain the mathematical model. So what is Mason's gain formula? Sigma Pk delta K upon delta, or 1 by delta multiplied by sigma Pk delta K. What is Pk? K number of forward paths. It varies from graph to graph. Number of forward paths depends upon the graph. In this case, number of forward paths equal to 2. Therefore, K varies from 1 to 2. What is delta 1? Delta 1 is nothing but delta for the part of graph which is not touching the forward path 1. What is delta 2? Delta 2 also delta. We have to find a delta which is not touching the second forward path. There is no graph which is not touching the first forward path and second forward path. Therefore, delta 1 equal to 1. Delta 2 also equal to 1. What is delta? Delta equal to 1 minus 1 minus sum of gain products of individual loops plus sum of gain product of all combinations of all possible combinations of two non-touching loops. We have to check L1, L2. We have to check L1, L3. We have to check L2, L3. How we can find from the expression itself, we can find how here G1 is common. If you see L1, L2, if you consider L1, L2, G1 is common. Therefore, definitely they are touching. If you consider L1 and L3, G3 is common. If you consider L2, L3, G3 is common. Therefore, they are touching each other. They are touching each other. Sometimes they may be touching, but there won't be common elements. That is also there. For example, you should be very careful. That's why I'm telling. Here, for example, here one more loop is there. That is G4, H4. These two are touching each other, but there is no common element. But L1 and L3 are not touching. L1, L4 are touching. Similarly, suppose here one loop is there. This is G5, H5. L2 and L3 are not touching, but L2 and this is L5. L5 are touching. L5 are touching, but there is no common elements. So don't take this as granted. Sometimes if you see L1 equal to what? L1 equal to, in this case, minus G1, H1. L4 equal to what? G4 minus G4, H4. But there is no common elements, but they are touching each other. They are touching each other. Therefore, we have to check. But most of the time, common elements will be there. Quickly you can remove them. Quickly you can remove them. Sometimes there won't be any common element, but they will be touching each other. How many? Two non-touching loops, L1, L2. In this case, let us check. How many non-touching, two non-touching loops? L1, L2 plus gain products of L1, L2, L1, L3. Am I correct? Plus L1, L5. That is also not touching. L1, L5 also not touching. Then take L2. L2. Take L2. With L2, L3 already wrote. L3, L1 already wrote. Only thing is L4. If you take L4, L5, if you take, they are not touching. L4, L5 are not touching. Am I correct or not? L4, L5 are not touching. Only one more loop, one more group you are getting. How many? Three non-touching loops are there? L1, L2, L3. Any other thing? L4, L5, one more you cannot find. L4, L5, if you take, you cannot find one more. Then only three non-touching loops. Only three non-touching. Only L1, L2, L3. That's all. For that, what you have to do is you have to take all the possible combination. L1, L2, L3, L1, L2, L4, L1, L2, L5. But no need to consider these two because already L1, L2 are touching. Why we have to consider? We have to use our IQ. That is the drawback with this system. We cannot use it as a formula. We have to apply our IQ. IQ means it is not formula. You have to use your IQ means it is not formula. It is a thumb rule, not formula. So Mason's gain formula is a thumb rule, not a formula. We can say, but if you miss something, the answer will be wrong. You have to assume it as a thumb rule. Now, so what we have seen, we have solved the sum in two ways. One is block diagram reduction technique and signal flow graph. But signal flow graph will be simpler than block diagram reduction technique. But you can verify whether the answer is correct or not. By using signal flow graph, you can verify the answer by using signal flow graph. You can obtain through block diagram. After obtaining through block diagram, you can verify through signal flow graph. That way you can use the signal flow graph if it is not asked. If it is asked, you can solve with the signal flow graph only. Okay.